Question 7. A researcher is testing two lightweight elastic springs arranged in parallel and attached to a rigid support. The springs share a single suspended platform. Spring A has a force constant of 4.0 newtons per centimeter, while spring B has a force constant of 6.0 newtons per centimeter. A downward external force of 150 newtons is applied to the platform so that the springs extend equally and share the load. Which of the following correctly gives the extension of the system and the force carried by spring A? This question tests our understanding of Hooke's law and how springs behave when they are connected in parallel. So let's begin by recalling what we already know. We know that Hooke's law tells us that the force applied to a spring is proportional to its extension. This relationship is written as F equals KE, where F is the force applied, K is the spring constant, and E is the extension. When two springs are arranged in parallel, the overall system becomes stiffer. This means the effective spring constant of the combined system is equal to the sum of the individual spring constants. Another important idea is that when springs are connected in parallel, they all extend by the same amount. The load applied to the system is shared between them, but the amount of force carried by each spring depends on its stiffness. Now let's think through the solution step by step. First, we write down the spring constants given in the question. For spring A, the spring constant is K1 equals 4.0 newtons per centimeter. For spring B, the spring constant is K2 equals 6.0 newtons per centimeter. Next, we determine the equivalent spring constant of the parallel combination. For springs in parallel, the equivalent spring constant equals the sum of the individual constants. So we write K equivalent equals K1 plus K2. Substituting the values gives K equivalent equals 4.0 plus 6.0. This simplifies to 10 newtons per centimeter. Now we consider the external force applied to the platform. The question tells us that the total downward force is 150 newtons. Next, we use Hooke's law to determine the extension of the system. For the combined spring system, the extension X is given by the total force divided by the equivalent spring constant. So we write X equals F divided by K equivalent. Substituting the values gives X equals 150 divided by 10 centimeters. When we simplify this, we obtain an extension of 15 centimeters. Now that we know the extension, we can determine the force carried by spring A. Since the springs are in parallel, both springs extend by the same amount, which is 15 centimeters. The force carried by a spring is given by Hooke's law, which states F equals K multiplied by X. So for spring A, we write F1 equals K1 multiplied by X. Substituting the values gives F1 equals 4.0 multiplied by 15. This gives a force of 60 newtons. So the extension of the system is 15 centimeters, and the force carried by spring A is 60 newtons. This is our final answer. What did we do? We first determined the equivalent spring constant for the parallel spring system by adding the individual spring constants. Then we used Hooke's law for the combined system to calculate the total extension produced by the applied force. After finding the extension, we used the same extension in Hooke's law for spring A to calculate the force it carries. Now let's consider a common misconception. Some students assume that each spring simply carries half of the total 150 newtons because the load is shared. However, the force does not divide equally unless the springs have the same stiffness. In a parallel system, the forces carried by the springs depend on their spring constants. The stiffer spring carries a larger portion of the load. We will quickly summarize now. All springs connected in parallel extend by the same amount, regardless of their individual stiffness. The effective spring constant of parallel springs is the sum of the individual constants. The extension of the combined system is found using X equals F divided by K equivalent. Once the extension is known, the force on each spring can be calculated using Hooke's law, F equals K multiplied by X.